important this. So, with energy in an ecosystem, okay. Energy in the ecosystem. There are two main, how do I want to put this, types of organisms. Okay, we're going to have our autotrophs. Okay, an autotroph is something that makes its own food. Okay, so think of plants. Okay, these are also known as producers. Okay, so autotrophs are something that makes its own food. We refer to them generally as producers. So they have to be able to use things like sunlight and inorganic substances to produce some sort of food. So plants do photosynthesis and they get glucose. It's a pretty observable trait there. Okay. But anyway, so autotrophs, be thinking of plants, be thinking of phytoplankton. That's really what an autotroph is. All right. The other one we have is a heterotroph. Okay, and heterotrophs, these are organisms that get their energy from eating other organisms. Okay, and we're going to have a couple different types of heterotrophs. One is going to be what we call a primary consumer. Okay, so primary consumer is something that only eats producers. So something that only eats producers, something that only eats plants essentially, or plankton, this will be also known as an herbivore. Okay, so anything that we can think of that only eats plants, cows, deer, all those sorts of things, those are herbivores. All right. Also, again, those are generally known as your primary consumer. Then we're going to have things that are referred to as carnivores. Okay, so carnivores, these eat essentially, how do I want to put this? Only other organisms that eat other animals. Okay, eat meat. Okay, and so these are things past your primary consumer, things that don't just eat plants. You can refer to them sometimes as a secondary or tertiary consumer, depending on where they are in terms of this thing called a food web or food chain, and we'll talk about that here in just 1 second. But essentially we have, those are your primary things, your autotrophs and your heterotrophs, your carnivores or your herbivores. Now, we have a couple of other ones that we can look at. We have omnivores. These eat both plants and animals. These are what humans are considered. Humans are omnivores. They eat or are designed to eat both plants and animals. You can have things like vultures. Those are called detritivores. And these are eat only dead organisms, essentially scavengers. Okay. And then finally, the last thing we have is a decomposer. Decomposer. So decomposers and detritivores sound similar, but they're different. Detritivores eat dead organisms, and decomposers also eat dead organisms, but decomposers break down dead organisms to put their nutrients back into the soil. Okay, so a detritivore, something like a vulture, doesn't really do the same thing as an earthworm. Okay, earthworms are breaking down soil, um, making it more nutrient rich. Vultures are just kind of eating dead things and uh, doing another important job, but essentially just some sort of job that you wouldn't be too worried about. All right. Does anybody have any questions about those roles? Those essentially those food roles.
Yeah, I do. So, like, what if there's like those animals that like live off of like bodily fluids, like the leech drinks blood. Like, how do they get their energy just by drinking blood all the time?
They're
Leeches
technically
would be,
carnivores.
yeah, leeches are heterotrophs. They would be considered a carnivore because they are, while they're not necessarily looking for the meat per se, they're still getting it from another animal. Does that make sense?
Yeah.
But yeah, I mean they're getting all their nutrients from some other organism. They would be your they'd be a secondary consumer. They do not eat plants. They essentially eat the blood of other organisms. So, um, does anybody have any other questions? Okay. So, if nobody has any questions, is anybody writing this down, or am I good to erase this? Get on to the next stuff.
Erase it.
Cool. Perfect. Thank you. All right. So, talking about the next set of things, what we need to talk about are essentially these things called trophic levels. Okay? And so a trophic level is going to be each step in a food chain / food web. Okay? And we'll talk about what food webs and food chains are, but essentially this is where each level you go up, there is something that is eating something else. And so food webs or food chains, the bottom trophic level in every ecosystem is always a primary producer. Okay, so it's always going to be some sort of plant and or phytoplankton. All right, and so we have those things. Now we have to look at what is a food chain. Okay, so food chains are the easiest way to look at things. Food chains are just a simple model that show how energy moves upward in an ecosystem. Okay? And so like a basic food chain would be something like, at the very, very bottom level, we have grass, okay? That is the primary producer. Then at the second level, our very first primary consumer. This is going to be something small, probably. I mean, deer would be a primary consumer. Let's go ahead and do deer then, okay? So deer would be our primary consumer. Now we need something that eats deer. Let's go ahead and put wolves, okay? Wolves would be our secondary consumers and the carnivore in this situation. So that's just a very simple food chain, very simple model but we can see that energy flows from grass into deer into wolves, okay? And that's if we're looking at one specific set of organisms. However, food chains are not a great representation of a whole ecosystem. You want to generally use a food web, okay? So food webs, these are a more complex model that allows the representation of all organisms and their relationships in an ecosystem to be represented. Okay. And so with these, I don't look at this. All right. This would be kind of what a food web looks like. Okay. At the very bottom level, berries or plantains, these are our primary producers. These are the autotrophs. Excuse me. These are the autotrophs. These are the things that make their own energy. Okay. And then we can see that there are some things that come off of that, these arrows. And essentially, things like the grasshopper, the butterfly, the green fly, the titmouse, the mouse, or the rabbit, all of those are going to be your primary consumers, okay? These are heterotrophs. They're eating the berries and the plantains, but they do not eat other organisms, okay? They are the very first ones that essentially only eat, there we are, plants, okay? Then we move it up. They call it a ladybird, but a ladybug. These eat these green fly things, okay? Now, green flies get eaten by ladybugs, and so that would make these ladybugs a secondary consumer, okay? A titmouse, while it also eats berries, does eat ladybugs, making it a kind of that omnivore thing that we talked about. It's a secondary and a primary consumer, but let's focus, since it does have an arrow coming to it from another organism, we'll focus on it being more of a secondary consumer, okay? Dragonflies eat ladybugs, okay? So we have one right here, we have primary, secondary, and then what we would call a third level up is a tertiary. So dragonflies that eat ladybugs, 1, 2, 3, would be a tertiary consumer, okay? I mean, and you can keep going. Frogs eat dragonflies, snakes eat frogs, buzzards eat snakes, okay? So boom, boom, boom. This is a really long chain, but we can see this, all right? Now, all of these things that have arrows going from it, so it doesn't matter if it is the frog has an arrow going from it to the snake, the titmouse has arrows going from it to the snake, the buzzard, and the fox, okay? The only organisms that do not have arrows going away from them are the buzzard and the fox, okay? Nothing in this ecosystem eats buzzards or foxes. So, what we would refer to those as would be a apex predator, okay? In this situation, they are the top carnivores, all right? I'm going to go ahead and reshare the whiteboard. Whatever organism is at the top of the food web or chain is known as an apex predator. okay? So nothing is really eating those things. The only thing that eats an apex predator would be detritivores or decomposers that essentially break it down once it's dead. Are there any questions so far? Okay. Let's move on to the last set of stuff that we've got. Thank you, Max. I'm going to go ahead and clear this. I'm also going to move this back over here. All right. So how we can kind of look at these are through what we call ecological pyramids. Okay. And 1 second, I am going to stop sharing this for just 1 minute. That way I can get it hooked up. And let me pull up this. This is what I want to pull up. Okay. All right. So we have essentially 3 different sets of these ecological pyramids. Okay. We can use these to look at all sorts of different things. And so the 3 pyramids we have in ecology are the energy pyramid. Okay. And this essentially is how much energy moves from your bottom level up each level. Okay. One thing we have to understand about these energy pyramids is that only 10% of available energy in each level moves up to the next level. Okay, so when you think about that, that's essentially saying, like, if we have a whole lot of grass, there's 100% energy in that bottom level. Those are our primary producers. Okay, grass has a bunch of energy. Only about 10% of that energy gets eaten by, let's just say, primary consumers, which would be like deer, mouse, all those sorts of things, and is used to make mass. Okay, the rest of it gets lost as heat because mammals and other organisms generally burn off energy. So only about 10% of it makes it there. Then the next level, then the next level. Okay, and so that available energy really dictates how many organisms can be at each level, which explains our next one, which is the pyramid of numbers. Okay, and so this essentially just kind of states that each trophic level you move up, there are fewer organisms the next level on the pyramid. Okay, so when you look at a pyramid, you know it has a wide base and then goes to a very small point. Okay, the most number of organisms you have is going to be your primary producers. You're going to have a lot of grass and shrubs and things that organisms can eat. Then your next biggest one is going to be primary consumers, things that only eat those plants. Then it's going to get smaller and smaller. Your secondary consumers, and if you have enough secondary consumers, you might have a tertiary consumer. Generally, it doesn't go a whole lot farther than a tertiary consumer. Okay. So the pyramid of numbers, and I'll show you guys this in just a second, but I want to talk about this. And the last one is a biomass pyramid. Okay, and this is essentially talking about the same thing. There is more mass at lower levels. Okay, and this is generally due to there being more numbers of organisms at lower levels. Okay, so there's just more mass the farther down you go in these ecological pyramids. Now let's go ahead and show this. Okay, and so again, these are those kind of these things I'm talking about. The energy pyramid, 100% here, and over here it's showing that heat is leaving. Okay, so again, you have 100%, and then 10% of that 100% moves up. So you have 10% at the first level, 10% of that 10% moves up. So you have at the second level consumers, you have 1% of the available stuff that there originally was. Then you go to the third level, so primary consumers, secondary consumers, these are your tertiary consumers. These are going to be, or there's only 0.1% of available energy from the very bottom that makes us all the way to the top. And that's why it kind of comes to a point like that, okay? Less and less organisms, okay? And that's what this is essentially showing, the pyramid of numbers, because we have less and less energy. Same thing with the middle one, your biomass pyramid. You have more mass here. Chickens need to use that mass, and they only get so much energy from it. And so when they eat that grain, you can only make so much chicken because some of that energy is being utilized as heat, lost as heat. And then at the next level up, humans eat so much chicken, but we can only make that much tissue due to the energy that we can use, okay? And so the numbers, the biomass, and the energy are all tied together, all right? Does anybody have any questions? I see somebody hitting the chat. Nope. Okay, so I'm going to stop sharing.